Good afternoon, ladies and gentlemen of Algebra 2 Honors. Good to have everybody here today. And that's one thing that's great about this class. You guys show up to class. Great work. What we're going to do is these first three problems, 14, 15, and 16, are similar to the ones like the set we were working on up until the end of yesterday. And so I want you to go ahead, especially work on 14, and then we'll just review it here shortly, okay? What do you think?
X is less than or equal to -6. Yeah. And then 4. X is greater than or equal to -16.
Let me just write those down. So Connor says X is less than or equal to -6, and X is greater than or equal to -16. Is that right?
Mm-hmm.
Does that look right?
Sure does.
What I want to do is, for the benefit, if no one else of the viewing audience, I'm going to go and demonstrate how that is, okay? Because we have an audience, right?
Yeah.
How big is our audience?
Very small.
Or has anybody checked how many views these videos get?
750.
They get a few a day right after they're made. In the day after made. So that's going to be 5, is that right?
Yep. Yes.
And so we have X plus 11 is less than or equal to 5, and X plus 11 is greater than or equal to -5. Is that right? And then if we subtract, so X is less than or equal to -6. Is that what Connor told us a short while ago?
Yep.
Yep. And -11. So if X is greater than or equal to -16. Okay? And then to put that on a number line, let me put that on a number line here. Is this more as or less as nest? Less as nest, right? So I'm going to put these here. I'm going to put -16, -6. Is that right? Is this gonna be closed or not closed? Yeah. I was just seeing if people were paying attention. Thank you for paying attention, Peyton.
Copy.
Good job, good job. Okay, any other questions on that or observations? Okay, did anybody do 15 yet?
Uh-huh.
You did? Well, if you haven't done 15 yet, I want you to take a minute and do 15. 15 and 16 are kind of interesting cases, I will say that. A lot of right hands working today. Is anybody left-handed in here? No. Usually I'll have one or two. Okay, what'd you get for this one?
I got x is greater than 7 and x is less than -1.
Okay, J got x is greater than 7 and, or was it greater than -7?
+7.
Positive. And
-1.
x is less than -1? Or that'd be or, right? Well, this is going to be a what? Less is nest. Anybody else get that? You got that too, Connor? Anybody else get something different? Riley, you get something different?
Yeah, I got 0 and 6.
0 and 6? So I'm just gonna put 0 and 6. I'll just put 0 and 6, just kind of on the side. Anybody else get something different on these? Okay, let's go ahead and go over this. First thing I would do is this +5 here, right? So we get -5 times quantity x minus 3 is less than 20, right? Then what? So we get absolute value of quantity x minus 3 is less than, what is 20 divided by -5?
-4.
-4. Okay, is that a correct?
Were you supposed to just
Don't
look
you
at
click the
signs?
sign when you divide by negative?
Yeah, so I wasn't sure about it.
So Connor, Jay, anybody else notice that? Did you notice that, Addie? Did you notice that?
I couldn't remember if I needed to flip the sign or not, so.
No, you did right. That's good. Very good. Good job. Good job. That's proof of you have validated being an AP in the Algebra honors today. Good job. So let's go ahead and work that out. So we got x minus 3 is greater than negative 4. Is that right? And also x minus 3 is what? Less than 4. Does that look right?
I know what I'm messing up.
So let's go ahead and add to that. So we get x is greater than negative 1, right? And over here we get, it's going to be plus 3. Oh, I'd be dangerous if I paid attention. And we get x is less than 7. So what happens is we have the same extremities that Jay got for us, right? But we have the signs are different. And was it right here, Jay?
Yeah.
Yeah,
I forgot
so-
to put negative 4 up at positive 4.
Oh, you did? Oh, okay, all right, all right. Yeah, it's easy to make mistakes in this. So anyway, what's our answer for this going to be? Does anybody see it yet?
Yeah, but that's not, yeah.
Let's go put that on a number line here. We got less than 7, so here's 7, right? Is that going to be like open or and less than, so we're going to go this way, right? And then we have the negative 1, and that's also going to be this thing, right? And which way do we draw this? A la derecha, to the right. So what is our answer to this thing?
Negative 9, less than x, less than 7.
Okay, look,
You're going to infinity, right? Did you go past that? Or you stop?
look. It's everything less than 7, including this negative 1. Everything greater than negative 1.
It's greater, you got it greater than or equal to and less than or equal to, right? Because if it's includes that.
Then we have this greater than, so it's greater than negative 1, everything greater than negative 1, including 7. So what is our answer for this?
All real numbers.
All real numbers. Now, let me tell you something. What happens is, when you get this situation like this situation right here, I'm going to box this in for emphasis. When you get this situation right here, this means all real numbers. In fact, I'm going to go ahead and put, this means domain is all real numbers. Okay? Why do we know that?
If any positive number is greater than a negative number.
Yeah, this thing here, so Ben, and correct me if I'm wrong, Ben, what's going to happen is the smallest this thing could possibly be is 0, right? So this is never going to be less than 0. In fact, it's going to be 0 only if x is 3, right? But still, 0 is going to be greater than a negative number, and so that's how you can tell that you have all real numbers.
Mr. G,
Yes, sir.
whenever you divide by a negative, is that why you flip the sign?
Yes, and we didn't talk about that in this class as much as we did in another class yesterday during second period. I want to give a demonstration here of 2 people in this classroom whose body weight differs greatly. And so I'd suggest using either Gabby or Addie as one of our contenders, and then someone else who wouldn't
Well,
mind.
Wait,
Riley.
Riley, you said something?
Do you care if we use your name, Riley? He doesn't, okay, so we're gonna have Riley over here. And who should we use? Should we use Gabby on this one? Gabby, yeah, Gabby, you're gonna be over here on this edge. Equidistance apart, right? So Riley's over here, Gabby's over here. Which way does the teeter-totter go? Goes like this, right?
Yeah.
Now, Riley, Gabby, I don't know how much you weigh, but it's probably in the neighborhood of 100 pounds, more or less, right?
She weighs 85.
Pardon me?
A little less.
A little less. We'll say 100, just to make the arithmetic easier. We'll say 100 pounds.
How much does Riley weigh?
He doesn't have to say exactly, but
Like 420 max?
About 420.
Nah, almost 300.
almost 300? Okay. So Riley, she was almost 300. I'll say 280.
Did he get it spot on?
So anyway,
Riley's like, sure.
Riley, the Wildcat offensive line could use you, I think.
Yeah, we really would. I really would.
No, really, you could be a force. And you look like you're mobile enough to actually play too.
Yeah, why did you play?
Yeah, he's not.
Little rubber boy.
Yeah, and if he's not interested, that's fine. All right, we're gonna try to talk Riley out of retirement today. Anyway, that's enough. But anyway, let's go ahead. But that's definitely the way things would go. And Riley's got to be careful because Gabby might be sent into orbit there, right? We don't want Gabby to be sent in orbit, do we? Okay, now let's say we go ahead and we multiply these things by -1. We make them negative, right? And so now Riley, instead of weighing negative 280, he weighs negative 280. And Gabby weighs negative 100, right? Now who's heavier?
Gabby.
Now Gabby's heavier.
Ain't Gabby so cool?
See, so I don't know, this is just a demonstration, just sort of a tangible demonstration of multiplying by a negative number, changing it all up, okay? So I don't know how helpful that was. We talked about that in the second period class the other day. All right. 16, did you work out 16 yet?
Mm-hmm.
No.
Oh, actually? No, yeah, I'm good. I'm good. Because you don't have to put the signs on this. I'm good.
You have
Can we
it?
only flip the sign when it's negative? Like
Yes.
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 Come on, Connor, were you not listening to that whole lecture?
No.
Connor was just busy working.
Yeah.
You used to be working.
That's another thing. A lot of times when I'm talking in class and demonstrating something, you might be focused in on something else, and it might be important for you to focus in on what you're focusing in on more than listening to me at the time, right? If you're sort of in a zone where you're actually being productively learning. Okay, what do we got for this one?
X is less than negative 5 and X is greater than negative 3.
Connor, can I look at my answer?
No.
X is less than negative 5,
Yes.
and X,
It's greater than 5.
I do it wrong.
Yes.
I get it wrong.
I got it. X is less than -5. and
Jay, what do you think?
-3.
I got negative 3.
so Jay got X is less than negative 5, and X is greater than 3, you said?
-3.
Negative 3.
That's what I could be all around numbers again.
Okay,
Did I mess up?
Any other- yes.
Not you. I got the bottom.
I got no
Ben got no solutions.
Ben probably was right. Just listen to Ben. Oh, no solutions?
Is it because it goes to the management?
Yeah, no solutions is gonna be it.
Yeah.
Let's go ahead, let's
It's
go ahead,
negative 3 hour, I did my,
let's go work it out here, right? So we work this out, we get 8 times
negative 8.
-8, then we divide by 8. And so we get absolute value of x plus 4 is greater, is less than, excuse me, less than -1. Is that a possibility?
Yeah.
It's not?
It is not a possibility. Why not? This thing here,
Oh, it can't be less than 0.
this thing x plus 4, absolute value of x plus 4 has to be greater than or equal to 0, right? If it's not, if you see a negative number, and it's just like when we go back here and we saw greater than a negative number is all real numbers, less than a negative number is no solutions. Okay? Now, this class, I'm really glad about something. Because we got a guy in here, and I know we have others too, but like Ben will get these answers right, but people did not wait. You didn't wait for Ben, right? That was good. Don't wait for Ben, or don't wait for anybody, right? Do just like you did today. Like this class does a lot. Yes.
Oh, no, this yours.
Oh, okay. Okay, now we come to this next set, which especially 17 through 21, but also 22, which they're really pretty much all the same type of problem. And what would you say? We'll talk about 17 for a little, and then we can work those out pretty fast, mostly. Well, what would you get for 17?
Through 70 or 60, yeah, 66 because you go down.
Okay, yeah, so Bryce says this, now correct me if I'm wrong, Bryce. So you're saying your temperature is going to be somewhere in between and possibly equal to, and I'm going to call that degrees F. Does that look pretty good?
Yes.
Looks real good. It's very common sense. I happen to, here's the odd thing about it, is we had somebody in 7th period class who was born about a minute after Bryce, who said the same thing. You know who I'm talking about. Bryce has a twin sister.
No.
What's her name?
It'd be funny if they named her like Haley or something.
Yeah, that'd be a real coincidence. Okay, yeah. Anyway, yeah, now, to me, the harder part of it is getting like an initial equation or inequality to work toward this. And what it is, we sort of talked about this, I think, was it yesterday? If you take x minus 68 and make our tolerance less than or equal to 2, that's how you'll get it, okay? Does that make sense?
Yeah.
And so we have,
Smart enough to not need that?
yeah, you could. Okay, Jay and asked a very good question. He says, are you smart enough to not need that? Yeah, but here's the thing, that where you can actually be analytical about it, I want you to be. And why is that?
To make sure.
possibly to make sure, but even more elemental than that. So because what happens is, a lot of times in mathematical uses, things aren't as intuitive as that, right? This is very intuitive, you can think that. And so being able to set it up is what enables you to figure out things that maybe aren't as easy and as intuitive. So that's why we're going to try to come back to these when we can. Sometimes it's hard to explain why. I know sometimes I get stuck on these things. So now,
Would it not be greater than or equal to -2?
yeah, greater than. Thank you. And you have to take that away too, right?
Jumped in.
Good catch. I was too busy explaining things. That's all right. So now we're going to be good, right? We have x is greater than or equal to 66. And this brings us back to what Bryce was telling us earlier, right? Okay, good. And if you look at especially 18, 19, 20, and 21, they're all very similar. And so I want you to work on those. 22 has it's a little tweaky because it's the same thing, but they ask you to make a conclusion based on that. So go ahead and work on those, and we'll go over them pretty quickly in just a few minutes, okay? So this is the setup inequality I'm showing for this situation here. Does that make sense? And so you're going to have S is going to be greater than or equal to 240
240, 400,
400.
and less than or equal to 400. We had another student in the second period who made an observation about inequalities. Is if you really think about it, in our real world, do we use inequalities more or equations more? Inequalities, right? What would be an example? Now this is one right here. What would be an example that you could think of that would be an inequality situation in your own life?
Like getting food, people.
Getting food from people?
Like if you're throwing a party or something.
Like if you're having a party or something? Yeah, so Jay's saying if you're getting food, you're going to want to have this amount or more, right? So that'd be like a greater than or equal to. I need to have greater than or equal to 2 dozen hot dogs, or something like that. Yeah, that's right. Okay. And then this one here, you have our squirrel, who is going to be, our squirrel's age is going to be between how many years?
6 1.5. Yeah.
One way you can write this down is 6.5 plus or minus 1.5, right? That's not an inequality notation, but you see that? You'll have 6.5 plus 1.5, which is 8, minus 1.5, which is 5. So that's going to be your range of ages that the squirrel lives. And if you put S minus less than or equal to 1.5, you'll get this, right?
Indeed, will.
And then we have this history situation, which is, what is this one going to be here?
Less what? Yeah, less than or equal to 1972.
So 1970, less than or equal to 1972, but
Greater than or equal to 1966.
now, and it so happens, do you remember the significance of landing on the moon in 1969? Pardon? What's the significance of that?
We beat the Russians.
We beat the Russians, and another thing we did,
We brought Neil Armstrong home.
brought Neil Armstrong home. Another thing we did is we fulfilled the prophecy of President Kennedy, who set that as his goal to reach the moon by the end of by a decade. So I don't know exactly when President Kennedy said that. It was probably 61 or 62 that he said that. See, within 10 years.
Did you know that Neil Armstrong, if you take the first letter of his last name and put it in front of his in front of his first name, it makes alien.
Alien?
Yeah. Like he put his name.
Oh no, I didn't know that.
Yeah.
So is that like a conspiracy theory?
Yeah. Neil Armstrong was an alien that we brought back from space. That's why I said we brought Neil Armstrong home.
Look at that. It's a conspiracy theory. Okay, speed limit is 30 miles an hour. This reminds me of a couple weeks ago when I was pulled over by a friendly police officer in Crandall. I was doing 65 and 55 zone.
Should you break it? Whoa, he's a real rapper now.
No, I'm one of those drivers that really tries to follow the speed limit very closely. But sometimes, like if you're not paying attention, you can just kind of go a little faster, which happened to me.
I paid for the
Yeah,
whole
especially like when the traffic around is going faster.
Yeah, well, this was, yeah, Bryce, you're right, when the traffic's going faster, this was not that case. This was me just driving alone. I don't have anybody to blame for it.
I paid for the whole speedometer, I'm gonna use the whole speedometer.
Yeah, sometimes I just look down and I'll be going 100 miles.
Yeah, it isn't marked up to 120 miles an hour for nothing, right? It's for a reason.
Pay for the whole thing, use the whole thing.
Yeah, Jay. Gotta be careful, that's how you can really get hurt. But anyway, fortunately I had a very nice police officer who just he just gave me a warning. But anyway, this one here, speed limit's gonna be 25 to 35. And then we can work it out. Now I want to talk a little bit about this last one because it's kind of interesting in light of what we are in the midst of, an election season, major election season, a little over a month away. We have our presidential election. And a poll of likely voters shows that the incumbent will get 51% of the vote. And I was asked in 7th period what an incumbent was. We know what an incumbent is? Yeah, an incumbent is a office holder that is currently in office. Okay, that is the incumbent. And so between President Trump and Vice President Biden, President Trump would be the incumbent president, and Vice President Biden would be the challenger. Okay, so that's how we'd say that. But anyway, poll of likely voters shows the incumbent will get 51% of the vote in the upcoming election based on the number of voters polled. The results of the poll could be off by as much as 3 percentage points. What does this mean for the incumbent? So what is the inequality here? So our vote percentage, we'll call it vote percentage, is going to be what? So 40 can be greater than or equal to 48%, but less than or equal to 54. Okay, what does this mean for the incumbent?
He could get messed up.
Yeah, that he could possibly lose, right? Now, what happens is this gets into an area of mathematics we call statistics. And why is, now this is typical that a poll it'll have a margin of error, like plus or minus 3 points. Why is there a margin of error?
Because it's not the same every year.
It's not every poll isn't always a whole number.
Yeah, it's not a whole number, but what's going to happen? What would we have to do to have no error? What would we have to do?
No one changed their mind.
No one changed their mind, but also what? Someone said over here. Okay, yeah, it has to do with that. Okay, what it has to do with is if we took a poll of every person who is voting in an election, we would find out, right, very exactly. But we can't do that, can we? Welcome to room 15, where learning comes first. All right, you'll be headed your way shortly. You're welcome. Miss Dominguez is asking for you, so I don't know if you'll be back by then.
Yeah, I just gotta pay her.
All right. So, anyway, to get a perfect, we'd have to go ahead and take that. Would it be feasible to poll everybody in the United States? No, it's not. And so we have to have less, and anything less than that is going to have a margin of error.
Outside of like proportional.
Now I want to show you. Here. There was there's a poll here recently. In fact, this is today from RealClearPolitics.com, and it has President Trump job approval. And they have all these different polls, and when the polls were taken, and they have these things here. It says 1500 LV. You know what 1500 LV means? LV stands for likely voters. Okay, and then 950 LV, and what is 889 RV? What does RV mean? RV means registered voters. And so what it is typically the likely voter polls are more accurate than registered voter polls because they're trying to be more discriminating about, is this going to be really accurate? Now, I think in this election season, I don't know how accurate, now this is job approval, but what they do is it costs to survey people. And so, would you expect a 1,500 likely voter survey to be more accurate than a 950 likely voter survey? Yeah, okay, and you work out statistics for that. So I thought that was kind of interesting. All right.